in example 7, we're going to do another quadratic application problems, but they're not going to be using X and Y like we are used to. It says if a ball is thrown upward at 96 feet per second from the top of a building that is 100 feet high, the height of the ball can be modeled by h equals, where t is the number of seconds after the ball is thrown. So we don't really need this information here, but you got 96 feet per second, and that's 96 t, so that's representing my velocity. We're at the top of a 100-foot building, so that's my constant, that's my starting point. And then again, that negative 16t squared, that's going to represent our gravity. All right, so notice that we are using t for the number of seconds. And we have, instead of y equals, we have the height, h. So part A wants us to sketch the graph of this model using the domain and range with non-negative t and h. And that should make sense in the context of this problem. If I have t is representing my number of seconds, I can't have a negative t because I'm not going back in time. Same with my h, if my h is height, I can't throw a ball in the ground, all of a sudden it starts going through the concrete and the earth and going down to its mantle, right? It's going to stop on the ground. So with these non-negative t and h, when we graph, we want our x min to be 0, and we want our y min to also be 0. Okay, and you can also think of this as, or we are graphing, I'm going to try to squeeze this in quadrant 1 of our graph here. So I got my x min at 0. Well, I guess let's type in the equation first, right? That's probably where we should start. So instead of t, I'm putting in x. So I have 100 plus 96x minus 16x squared. And then in my window, my x min is 0. Now I don't know what an x max should be. It doesn't tell me that information, so we just have to guess it. I'm going to put in 10. I don't think this ball will be up in the air for more than 10 seconds. So I'm going to go with a 10. Scale of 100 is good. My y min needs to be 0. And then y max, we're throwing it off a 100-foot building. I don't think it's going to go more than twice that, so I'll go 200. And I'll make that a scale of 25, but scale's not important really. And I'm going to hit graph. And there is my graph. So you can see how the ball is traveling. What I don't see is how high this is going. I don't see the top number here. So when this happens, just play around with your window. I didn't think that the Y would go higher than the 100-foot building. So let's just try 300 and see if that can get that vertex in there. And there it is. Okay, so just play around with the windows. You get the whole thing. And so this should kind of make sense. If we throw this ball, it's going to go up, it's going to travel up and then come down right there. So that is quite the velocity to make that go up so high. Okay. So check. Part A, we have graphed. Part B, is the function increasing or decreasing for t between 0 and 3 seconds? So if I do trace 3 here, that looks like it could possibly be the vertex. So between time 0 and time 3, how is this function behaving? Well, that is increasing. Now, C wants to know what is the positive h-intercept of this graph. So what are they talking about here? Well, usually this is y equals and it's h equals. So they're talking about this y-intercept here. So we can do this one of two ways. If I just use my equation and plug it in, to have an h-intercept, that means my t would have to equal 0. So I'm going to plug in a 0 for t. So I have 100 plus 96, oops, times 0. Minus 16 times 0 squared. This one's very easy to compute. 96 times 0 is 0. 0 squared 0 times 16 is 0. So we're left with this 100. So that means we have a h-intercept at 0, 100. Now, how else could I have found this? Well, if I already have the graph, if I do trace 0, I also get a y of 100, which should make sense because if we're talking about that sketch, where is it starting on this y or this h axis right here? It's starting on that 100-foot building. So we could do an or trace 0, enter to get the same thing. So what does the h-intercept mean in the context of this application? Well, I kind of just explained that, right? That should make sense because what is this starting at? It's starting at the height of this building that's 100 feet high. So you can answer it one of two ways. You can say the height of the ball before it's thrown. Or simply the height of the building.